Wayne mentioned skewness earlier and showed some examples. Let's take a closer look at skewness in terms of mean, median, and mode. Data can be normally distributed. The shape of a normal distribution is often called bell-shaped because the data is distributed symmetrically around the midpoint of the data. In such distributions, the mean, median, and mode are clustered together. Some histograms will show a skewed distribution to the right. A skewed distribution to the right is said to be positively skewed. In this kind of distribution, you have a large number of occurrences on the left side of the chart and fewer in the upper values or the right side, so the tail goes to the right, thus a right skew. Some histograms will show a skewed distribution to the left. A distribution skewed to the left is said to be negatively skewed. This kind of distribution has a large number of occurrences in the upper values or the right side and fewer values in the lower or left side. The distribution of the mode is greater than the mean and the median. Now we can also look at some other shapes that distributions can take. For example, some distributions may be bimodal, meaning it has two peaks. This shape may show that the data is being affected by two different sources. If this shape occurs, the two sources should be analyzed separately. In a bimodal distribution, the mean and median may actually cluster together, and you might assume the distribution is normal if you don't plot the data in a histogram. Although measures of central tendency are important in understanding your data, sometimes visually inspecting it can also provide you good insight. A uniform distribution shows little variation across your bins or categories. This type of distribution could occur because you have combined the sources of variation in your visualization or because your bins are too small or too large. Changing the way you are creating your histogram can provide more information about the actual distribution of your data. Finally, a distribution might be random, which means it has no apparent pattern. It may describe a distribution that has several modes or peaks. It could occur for the same reasons a uniform distribution does. Similar changes might provide more insight into the distribution of your data. Finally, histograms are valuable tools because they allow us to better understand the shape or distribution of our data. In general, we want our data to be normally distributed. When it's not, it's what we call skewed, with data clustered at one end or the other. If our data are normally distributed, we know that 68% of the data fall within +1 or -1 standard deviations of the mean, 95% within 2 standard deviations, and 99% within 3. And as I mentioned, most statistics assume normality. If not normal, although we can run the statistic, the results that we will get will be uninterpretable or worse, lead to the wrong conclusions.